All right, Honors Algebra 2. Welcome to the second half of your 6-1, 6-4 game plan, section 6-3-6-4. Yours looks a little bit different. We are graphing f of x equals the square root of x, or y equals the square root of x, the square root generic function. What values can x have? So anything is 0 or more can't take the square root of a negative. Then we have I. You don't have to graph I yet. So 0, 1, 4, and 9 I use because the square roots of those numbers are nice. So we plotted them just like we'll do in class. All right. So I can have any value of x that's 0 or more, and the smallest y value I'll get is also 0. So the domain is x greater than or equal to 0, and the range is y greater than or equal to 0. So you'll see that when I have y equals the square root of x, the graph will go something like this. And when I have y equals the opposite of the square root of x, the little graph will go something like this. Okay? So identify the domain and range of each function. So we're going to see what's the smallest x value that's allowed. Again, because I'm allowed to take the square root of 0, I figure out what value of x will make this 0. So I set x minus 7 equal to 0, and 7 is the smallest x value I can plug in there. So the domain is any x greater than or equal to 7. Now when I plug 7 in here, I get 0. So my smallest y value is going to be 0 plus 9. So this number right out here is the smallest y value. Notice here it was plus 0. That's why the range was y greater than or equal to 0. So the range here is y greater than or equal to 9. We got a few just like this. So number 2, I set what's inside the square root equal to 0. So negative 4 is my smallest x value. So the domain is x greater than or equal to negative 4. When I plug negative 4 in here, I get 0. 0 plus 7. 7, the range is y greater than or equal to 7. It's going to make this graph again, two straight ones that make that graph. Now this one's a little different. The opposite, see, and we'll talk here in a second. So I still set x minus 1 equal to 0, and 1 is the smallest x value I can have. Now let's say I plug 2 in for x. So obviously when I plug 1 in for x, I get 0. 0 times the negative 2 is still 0. 0 plus 3 is 3, so my range is going to involve 3. I can put y in 3. But what if I if I plug like 2 in for x, 2 minus 1 is 1. The square root of 1 is 1. 1 times a negative 2 is a negative 2. Negative 2 plus 3 is 1, which is smaller than 3. So the range is less than or equal to 3. So if you have a negative on the outside, your range is going to be y less than or equal to some number. Okay? So that's what we got here on 4. Again, I set x plus 7 equal to 0. Negative 7 is the smallest. We'll see when it's not the smallest x value I can have. All right, so my range is going to involve y, and it's less than or equal to because I have that negative on the outside. Bigger numbers I plug in for x, I'm going to have a bigger number times a negative, which is really going to be 9 minus whatever that is. So 9 is the largest value of y I'm going to have. Set x minus 2 equal to 0, I get 2. Domain is x greater than or equal to 2, and I'm not, when I plug 2 in for x, I get 0 times 3. Smallest y value, smallest because it's positive 3, so it's going up as x gets bigger. Smallest y value is 0. All right, 6, I set, I don't worry at all about that number on the outside, because when I set x plus 4 equal to 0, I get negative 4. All right, that is the smallest y value no matter what. The smallest x value. Okay, when I plug negative 4 in for x, I get 0. The square root of 0 times 2 is still 0. So my smallest y value, because that's a positive 2, is negative 10. Y is greater than or equal to negative 10. 7. All right, be careful here on 7. Set x minus 1 equal to 0. Again, 1 is the smallest x value. I'm allowed to plug in 2, 3, and so forth. I can't plug in 0 because then I have the square root of a negative 1. That's a negative on the outside, so as x gets bigger, y is going to get smaller. The graph's going to go like that. So the range is y less than or equal to 3. 9. So this whole page, the domain is x is greater than or equal to some number. That might change here. I said 2x minus 5 equal to 0. The domain is x is greater than or equal to 5 over 2. That's a positive. It doesn't matter if it's a fraction. The range is y greater than or equal to 6. The graph's going to go up. And 9, very much like number 1, I said x minus 4 equal to 0. Domain is x greater than or equal to 4. Range is y greater than or equal to 2, because that's a positive square root. All right, so then we got hashtag game time. There we go on 10. Everything positive 4 on the outside. X minus 2 set equal to 0. Both the domain and range are going to be x greater than or equal to something, y greater than or equal to something. All right, here's where I have to be careful. I said 10 minus 2x equal to 0. I get 10 is equal to 2x. X is 5. And now that is the largest x can be, because if I plug 6 in here, I get 10 minus 12. I get the square root of a negative 2. So the largest x can be is 5. Domain is x less than or equal to 5. It's a positive number. Inside is I'm allowed to plug in values of x, which will actually get smaller. So y value will get bigger. 13 is the double whammy. I said 7 minus x equal to 0. I get x is 7 again. Look at that negative. That is the largest value that x can be. So domain is x less than or equal to 7. This negative root on the outside means that is going to be the largest y value I'm allowed to have. The range is y less than or equal to 1. Again, we'll review 4 more of these, and we talked about these in class. 2x plus 8 equals 0. Domain is x greater than or equal to negative 4. And that's a positive 5 on the outside, so the graph's going up. Y greater than or equal to negative 3. On 18 here, x minus 6 equals 0. X equals 6. Domain, x greater than or equal to 6. That's a negative on the outside. Square root, as x gets bigger, y gets smaller. The range is y less than or equal to 8. All right, here we are on section 6.4, which is pretty easy. Simplify, no decimals. Square root of 100 is 10. 10 times 10 is 100. Square root of 81 is 9. That's how we break down roots. 4 times 5. 4 is 2 and 2, so 2 root 5. Square root of 45. 45 is 9 and 5, so and 9 is 3 and 3, so we got 3 root 5. And there's 5. Pair of 3, pair of 2 break out of jail. You have 6 root 2. So on 2, I'm putting an imaginary 2 on the outside. I'm taking the second root of 100, which is 10. And then I'm asking myself, how many pairs of y are there in 8s? So I have 8 y's, and how many pairs do I have? A y squared, y squared, y squared, y squared. That's 4 pairs. Or I can simply do 2. I can do, how many times does that 2 go into 8? 8 divided by 2 is 4. 10y to the second, or to the 4th. All right, same thing here. What is the second root of 49? It's 7. How many times does that imaginary 2 go into 8? 4. How many times does that imaginary 2 go into 12? 6. These are all going in cleanly. Next game plan will be different. 2 goes into 16 4 times. 2 goes into 10 5 times. Sorry, 2 goes into 16. The square root of 16 is 2. The square root of 16 is 4. Goodness, I should honestly pause this and edit it. The square root of 16 is 4. 2 goes into 10 5 times. We're going to be air-free here. The second root of 121 is 11. The square root of 121 is 11. 2 goes into 4 twice. There are 2 partnerships if you have 4 x's. There are 7 partnerships if you have 14 y's. Here we are on number 5. The second root of 64 is 8. 2 goes into 2 one time. 2 goes into 4 twice. 2 goes into 10 5 times. On 6, the second root of 196 is 14. 2 goes into 6 3 times. 2 goes into 14 7 times. Now I'm talking about the third root, which we should kind of be good at from 5 5 5 8. The third root of 64 is 4. This time I'm looking for triplets. If I have 9 x's, how many ways can I put them in groups of 3? How many groups of 3 can I have? 3. 3 goes into 15 5 times. 5 goes into 20 4 times. If I have 20 x's and I need groups of 5, I'm going to have 4 groups. If I have 30 y's and I need groups of 5, I'm going to have 6 groups. Then the third root of 27 is 3. 3 goes into 18 6 times. 3 goes into 15 5 times. It's c to the 5th. I know that's weird. All right, game time. Here we are on 11. 4 goes into 12 3 times. 4 goes into 20 5 times. The fourth root of 81 is 3. 3 to the fourth is 81. 4 goes into 4 once. 4 goes into 12 3 times. The third root of negative 27, it's not imaginary, but it's negative 3. Negative 3 to the third is a negative 27. 3 goes into 15 5 times. 3 goes into 9 3 times. The second root of 64 is 8. Again, put the imaginary 2 on the outside. 2 goes in 8 4 times. 2 goes into 4 twice. The third root of 6 is 2. 3 goes into 6 2 times. 3 goes, I'm just spouting off things. Not true. 3 goes into 6 2 times is what I was thinking. Okay. There are 6x plus 2s. I'm going to put them in groups of 3. So I'm going to have 2x plus 2s in each group. That's a way to think of it. This imaginary 2 goes into 6 3 times. This imaginary, this 3 goes into 12 4 times. All right, this video needs to be over soon, as I am clearly tired. Square root of 144 is 12. This imaginary 2 goes into 6 3 times. That imaginary 2 goes into 10 5 times. The third root of 64 is 4. 3 goes into 6 twice. 3 goes into 15 5 times. Fourth root of 16 is 2. 4 goes into 4 once for the x's. 4 goes into y 25 times for the y exponent. Lastly, 5 goes into 10 twice. You have 10x plus 2s. You're going to put them in groups of 5 each. You will have 2 of those groups. Might have said that wrong on the previous one. I like this. Groups of 5, you're going to have 2 of those x plus 2s. 2 of those types of groups. Or 5 goes into 10 2 times. Okay, there we go. Again, might have made a boo-boo on this previous 21 if I'm thinking about it. You will have 12 of these x minus y's. You want them in groups of 3. There will be 4 of those groups. That is x minus y. Okay, that is it, folks. This is the Yak Math video signing out.